Hello students, in today's lecture I will discuss about clipping and types of clipping. Clipping is a procedure that identifies those portions of a picture that are either inside or outside of a specified region of space. Then in clipping we are having one window that is known as clip window. Clip window is the region against which an object is to be clipped. It may be a polygon or curved boundaries, but rectangular clip regions are preferred because whenever you are choosing a rectangular clip window, in that case you have to perform less calculations. But if the boundary is curved, then in that case we have to perform more operations. For viewing transformations, picture parts within window are displayed. Everything outside window area is discarded. So in clipping, what is happening, whatever the portion of the picture which is coming inside the clipping window, that we are displaying, and the rest of the portion that is outside the window, that we are not displaying, that we are ignoring. You can see that this is the object that we want to display on our computer screen, and basically this object is basically initially it is uh, drawn on world coordinates. A scene is made up of a collection of objects specified in world coordinates. So whatever scene that we are drawing, the dimensions of the scene are specified in terms of world coordinates. Now after that we are having one window, and this window is basically what it is, a clip window, and whatever the portion which is inside the window, this portion we make it as visible on the display unit, and the portion which is outside this window, that is invisible. When we display a scene, only those objects within a particular window are displayed, and you can see that the dimensions of window are xw minimum, xw maximum along the x-axis, and yw minimum and yw maximum along the y-axis. Because drawing things to a display takes time, we clip everything outside the window. So the part which is not inside the window, that portion is going to be clipped, and the portion which is inside the window, this is going to be visible. Now there are so many types of clipping. First is point clipping, then we are having curve clipping, then text clipping, exterior clipping, line clipping, and we are having area clipping. Now we will start from point clipping. That means you can see that we are having so many points, and whatever the points we are having, initially we are plotting all those points on the world coordinates, and the points which are outside the window, those points will be clipped and those points will not be saved. That means they are not going to be displayed on the output unit. Clip window is a rectangular in shape. As we know that we are taking the window as a rectangle, because whenever you are taking the window as a rectangle, you have to do less calculations. Any point can be defined in terms of p is equals to x comma y. So normally the point that we are representing is on that two-dimensional coordinate system, and each and every point is having a value of x coordinate as well as the value of y coordinate. So the point p is equals to x comma y is saved for display if the following inequalities are satisfied. That means what is happening, we are substituting the value of the point in these two inequalities, and if these two inequalities are satisfied, we make the point for display. And the first inequality is xw minimum is less than equals to x less than equals to xw maximum, and yw minimum is less than equals to y less than equals to yw maximum. And we know that y minimum, y maximum, y minimum along the y-axis and y maximum along the y-axis, these are the dimensions of our clipping window. If any one of these four inequalities is not satisfied, you can see that here we represent it in form of two equations, but normally there are four inequalities. First is the value of x is greater than equals to xw minimum. Second is the value of x is less than equals to xw maximum. Third is the value of y is greater than yw minimum, and the value of y is less than equals to yw maximum. So we are having four inequalities, and if any of these inequalities are not satisfied, that means the point is going to be clipped, and if the point is going to be clipped, that means the point will not be saved for display. Can be applied to scene involving explosions or sea foam that are modeled with particles points distributed in some region of the scene. So we can apply the point clipping in some application areas where the object is in a form of point, and whatever the portions which is coming in the clipping window, that we kept for display, and remaining points we are ignoring. So you can see from the figure, we are so many points are there. We are having point P1, point P2, then we are having P4, P7, P10, P5, P9. And we know that some of the points are inside the clip window and some of the points are outside the clip window. And the points which are outside the clip window, these all points are going to be clipped, and these points we are not keeping for display. A point x comma y is not clipped if wx minimum is less than x less than equals to wx maximum, and wy minimum is less than equals to y less than equals to wy maximum. Okay, so if this inequality is going to be correct or satisfied for any point, the point will be kept for display, otherwise it is going to be clipped and it is not considered for saving. Then we are having the next clipping, that is known as curve clipping. Curve clipping procedures will involve non-linear equations, so it requires more processing than for objects with linear boundaries. So you can see that here we are having an object and it is a kind of circle, and we are applying the clipping, and whatever the portion which is inside the window, that portion will be kept for display, and the remaining portion we are discarding. So the objects which are circular, these objects require more calculations. Then we are having text clipping. So normally text clipping is what we are performing, clipping on text. That means the characters or the strings. Depends on methods used to generate characters and the requirement of a particular application, and the methods for processing character strings relative to a window boundary. So in this we are having three cases, and first is all or none string clipping strategy, second is all or none character clipping strategy, and third is clip the components of individual characters. So in this we are having three figures. You can see in the first figure the string 1 portion, some of the portion of the string 1 is outside the clipping window, and some of the portion is inside the clipping window. So in that case we are completely ignoring the string 1, and we know that string 2 is entirely it is in the clipping window, so we are keeping this for display, and this string 1 is going to be clipped. In the second, we are performing the strings on the individual characters, and you can see that in the string 1 stri, these four characters are the outside the clipping window, so these four characters are not kept for display. While here you can see that str is inside, while ng2 is outside, while I is on the window. So the portion which is outside or on the clipping window, we are not keeping those portion, and we are completely ignoring that portion. In this case you can see that half of the character is inside the window and half of the character is outside the window, so we will keep the half character inside the window for display, and similarly the same case for the string 2 as well. Then we are having exterior clipping. Exterior clipping is just opposite of interior clipping. So in exterior clipping, whatever the portion which is inside the window, that we are not displaying, and the portion which is outside the window, that we will keep for display. Clip a picture to the exterior of a specified region. The picture parts to be saved are those that are outside the region. For example, in multiple window system, you can see that here we are having the various windows, and for example you can see that whatever window we are choosing, it is a kind of clipping window, and the portion which is outside this window, this portion we will keep for display, and the portion which is inside the window, you can see it is represented in form of dark color. This portion we are not displaying, and the portion which is outside the window we are keeping it for display. Then we can see that line P1 P9, the half portion of this line is inside the window and half portion is outside the window. So the portion which is inside the window, that portion we will keep for display, and the rest of the portion which is outside the window, that portion we are ignoring. And similarly we are doing for line P7 P8. So we can see that a line clipping procedure involves several parts. Test a given line segment to determine whether it lies completely inside the clipping window, whether it lies completely outside the clipping window, or we can see that the line may perform intersection with the clipping window. That means the line is partially inside the clipping window and partially outside the clipping window. A line with both endpoints inside all clipping boundaries is saved. A line with both endpoints outside any of the clip boundaries is discarded. Other line crosses one or more clipping boundaries and require calculations of multiple intersection points. So we are having three cases: whether line is completely visible or completely invisible, or it is partially visible. So here you can see in the figure, these two lines are completely inside the clipping window, so these two lines are not clipped. These two lines will be kept for display. Here we have to clip the portion of the line which is inside the clipping window, and similarly in this case also. In this case what is happening, the one point is inside the window and other point is outside the window, and in this you can see that both the portions are outside the window, but still some portion is inside. And similarly we could have another case also, both the portions are outside but still the line is not visible. And then we could have area clipping. Similarly to lines, areas must be clipped to a window boundary. Considerations must be kept as to which portions of the area must be clipped. So you can see in the figure, the portion which is coming inside the window will be kept for display, and this portion is visible while the rest of the portion is not visible. So in this way we could able to perform area clipping. Thank you.